Everyone knows the Union Pacific Big Boy. 4,014 tons of American steel, the largest steam locomotive ever built, a machine so iconic that 8 of them still exist in museums across the United States. For decades, railroad enthusiasts have called it the King of Steam, the ultimate achievement of locomotive engineering. But in 1950, when a crew from Union Pacific visited Japan on a goodwill tour, they encountered something that shook that certainty to its core. The Japanese National Railways had invited them to witness their newest creation, the C63 Class locomotive. On paper, the spec seemed almost laughable compared to the Big Boy. Smaller, lighter, built by a nation still recovering from wartime devastation. But when the Union Pacific engineers saw it move, when they watched it haul a test train up grades that would have challenged anything in America, something changed. The offer was made, a friendly race, 2 locomotives on parallel tracks, American power versus Japanese precision. The Big Boy crew declined, not because of diplomacy, not because the tracks weren't compatible or the conditions weren't right. They declined because they'd done the math, studied the performance data, and realized something the history books would later try to forget. The C63 wasn't just competitive. By every meaningful measure of locomotive efficiency and power-to-weight ratio, it was superior. This is the story of how Japan, in the ruins of defeat, built a machine that challenged everything American railroading believed about steam power, and why almost nobody today has heard of it. The year was 1947. Japan's rail network lay in tatters, bombed bridges spanning empty air, twisted rails leading nowhere. The occupation forces controlled everything, including the railroad system that had once been the pride of the empire. But deep in the drawing offices of the Japanese National Railways, a group of engineers led by Hideo Shima were working on something extraordinary. Shima had studied the great locomotives of Europe and America before the war. He understood the Big Boy's philosophy: overwhelming size, brute force, enough mass to crush any gradient through sheer weight and power. But Japan didn't have the resources for that approach. Steel was rationed, coal was scarce. Every pound of metal had to justify its existence. So Shima went in the opposite direction. He designed the C63 around a principle that American engineers had largely abandoned: thermodynamic efficiency over raw power. Every component was calculated to extract maximum energy from each pound of coal. The boiler used a combination of superheating and compound expansion that pushed thermal efficiency to levels Big Boy's designers had considered impractical. The valve gear was machined to tolerances measured in thousandths of an inch, reducing friction losses that American locomotives simply accepted as inevitable. The first C63 rolled out of the Kawasaki Heavy Industries works in December 1948. It weighed 230 tons, less than half the Big Boy's mass. 4 driving axles instead of 8. A single articulated unit instead of the Big Boy's complex mallet configuration. To American eyes, it looked almost delicate. A precision instrument next to the Big Boy's sledgehammer. Then they fired it up. The boiler pressure hit 300 pounds per square inch, 50 higher than the Big Boy's standard operating pressure. The compound cylinders, high pressure driving the first set of wheels, exhaust steam driving the second, created a thermodynamic cascade that squeezed energy from the steam that would have simply blasted out a Big Boy's stack. At full throttle, the C63 developed 28,000 pounds of tractive effort. The big boy, with twice the weight and 8 driving wheels, produced 61,000 pounds. Simple math suggests the big boy would dominate, but locomotives don't work on simple math. Power-to-weight ratio tells the real story. The big boy generated 14.6 pounds of tractive effort per ton of locomotive weight. The C63 generated 122 pounds per ton. That efficiency translated into something American railroaders had rarely considered important: acceleration, grade climbing, without excessive weight-destroying track, fuel consumption that made operations economically viable. When Japanese national railways ran comparative tests in 1949, the numbers were undeniable. Hauling a 1,000-ton freight train up a 2% grade, steep by American standards but common in Japan's mountainous terrain, the C63 consumed 38% less coal per ton-mile than comparable American designs. It could accelerate that same train to 60 kilometers per hour in less than half the distance a big boy needed. And because it weighed so much less, it inflicted minimal damage on the track structure, eliminating the constant maintenance American railroads accepted as the cost of running heavy locomotives. The Union Pacific delegation arrived in the spring of 1950. The Korean War had just begun, and the U.S. military was using Japanese rail infrastructure to move supplies. The visit was part goodwill tour, part technical assessment, American engineers examining what the occupied nation had managed to build from the ashes. They expected to see serviceable machines, basic designs that got the job done. Instead, they encountered the C63. The demonstration run took place on the Tokaido Main Line, the primary corridor connecting Tokyo to Osaka. Japanese National Railways arranged a test train of 40 freight cars, 1,500 tons total, a respectable load by any standard. The grade profile included sections running 2.5%, challenging terrain that would have required helper locomotives on many American routes. The C63 took the train alone. No helpers, no second locomotive, just that 230-ton machine and 1,500 tons of steel behind it. From the observation platform, the Union Pacific engineers watched the locomotive accelerate smoothly out of Tokyo, steam pressure holding steady at 300 pounds, the compound cylinders driving with a rhythm distinctly different from American power, quieter, more controlled, less of the dramatic bark and hammer that characterized big boy operations. At the base of the first major grade, the speedometer still read 55 kilometers per hour. American protocols would have called for a helper locomotive to be coupled on. The C63 didn't slow down. Up the grade, steam pressure, rock steady, valve gear articulating with mechanical precision, the locomotive maintained 40 kilometers per hour all the way to the summit. The coal consumption meters showed fuel usage that made the American fireman visibly shake his head. One of the Union Pacific engineers pulled out a slide rule, ran calculations, looked at the numbers again. At that moment, watching that smaller, lighter, Japanese machine haul a train up a grade that would have challenged anything in America while burning a fraction of the coal, something fundamental shifted. This wasn't just good engineering. This was a different philosophy of power, one that made the big boy's approach look almost crude. During the evening reception, a Japanese official made the offer, half joking, half serious, delivered with the careful diplomacy of occupied meeting occupier. Perhaps a friendly competition, your big boy against our C63. We could arrange parallel tracks, identical trains. The Union Pacific chief engineer smiled politely. Then he declined. The official explanation was logistics. The big boy wasn't in Japan. Arranging such a test would require massive coordination. The track gauges were different. Standard gauge in America, narrow gauge in parts of Japan. All true, all reasonable. But later that night, in the hotel bar, one of the American engineers spoke more honestly to a colleague. "We'd lose," he said quietly. "Not in raw pulling power, but in every metric that actually matters for railroad operations. Fuel efficiency, acceleration, track wear, maintenance costs. That Japanese machine does more with less, and everyone in that observation car knew it." The conversation was never recorded officially. It appears in neither Union Pacific archives nor Japanese National Railways documents, but it circulated through railroad engineering circles, a whispered acknowledgement that the assumed supremacy of American locomotive design had been challenged by a nation that had supposedly lost everything. So why did history forget the C63? Part of the answer is simple geography. Japan's rail network, remarkable as it was, existed on an island nation most Americans would never visit. The C63 ran on domestic lines, hauling freight and passengers through mountain passes and along coastal routes that Western railroad enthusiasts rarely saw. Without the global visibility of American transcontinental railroading, without the marketing power of Union Pacific's promotional machine, the locomotive remained invisible to the wider world. But geography alone doesn't explain the silence. The real reason cuts deeper, touching on the uncomfortable reality of how engineering reputation gets built and maintained. American locomotive builders in the post-war era had invested enormous capital and reputation in the big is better philosophy. The big boy wasn't just a machine, it was a statement about American industrial supremacy, a symbol that the nation could build bigger and more powerful than anyone else. Railroad companies had purchased hundreds of large locomotives based on that philosophy. Maintenance facilities were built around heavy power. Operating procedures assumed high fuel consumption and heavy track maintenance as unavoidable costs. Acknowledging that a Japanese design had fundamentally superior efficiency would have required admitting that billions of dollars in American railroad infrastructure was based on flawed assumptions. It would have meant confronting questions about why American engineers, with vastly greater resources, had been outdesigned by a team working in a defeated nation with limited steel and scarce materials. The institutional momentum was overwhelming. Railroad trade journals barely mentioned the C63. American engineering schools didn't study its design innovations. When Japanese national railways published technical papers detailing the locomotive's performance, few American engineers read them. Those who did often dismissed the results as statistical anomalies or measurement errors, unable to accept that their fundamental approach might be inferior. Meanwhile, the C63 continued working. Through the 1950s, it hauled freight across Japan's mountainous terrain with relentless efficiency. Fuel consumption remained a fraction of comparable American locomotives. Track maintenance costs stayed low. Crews praised its smooth operation and reliable performance. Japanese national railways built additional units, refining the design with each iteration. But by the mid-1950s, diesel-electric locomotives were emerging as the future of rail power. Both Japan and America began transitioning away from steam. The question of which steam locomotive design was superior became increasingly academic. The big boy was retired from regular service, some units preserved as monuments to American engineering. The C-63 ran until 1968, then was quietly scrapped, its superior efficiency suddenly irrelevant in the age of diesel. Today you can visit the big boy. 8 of them exist in museums, massive and imposing, their size and power undeniable. The largest steam locomotive ever built, the signs proclaim. Crowds gather to marvel at the engineering, to photograph the immense driving wheels and cathedral-sized boiler. Of the C63 class, nothing remains. No preserved examples, no museums dedicated to its memory. A few technical drawings survive in Japanese National Railways archives. Some black and white photographs show the locomotive in operation, hauling trains through mountain passes, steam trailing from its stack, but no steel, no brass, no physical evidence that this machine ever existed. The irony is almost perfect. The locomotive that could outperform the most famous steam engine ever built, that represented a fundamentally superior approach to thermal efficiency and power-to-weight ratio, has been erased from history while its inferior rival stands in museums as the pinnacle of steam engineering. Was the big boy impressive? Absolutely. Was it the largest steam locomotive? By tonnage and physical size, yes. But was it the best? That question depends on how you define best. If best means biggest and most powerful, in absolute terms, the big boy wins. If best means most efficient, most economical, most sophisticated in its thermodynamic design, most advanced in its power-to-weight ratio, then the answer sits rusting in a Japanese scrapyard decades ago. Unknown to most railroad enthusiasts, the crew that declined to race understood this. They'd done the math, seen the performance data, watched that lighter Japanese locomotive do things the big boy couldn't match. They knew that in a competition measuring efficiency rather than raw power, American steam would lose. So they declined, and history recorded it as a scheduling conflict rather than an admission of technical inferiority. Sometimes the most powerful machines aren't the ones that lift the most weight. Sometimes they're the ones that do more with less, that solve problems through precision and efficiency rather than brute force. The C63 proved that principle. Then it disappeared, leaving behind only archived technical papers and fading photographs, evidence of an achievement the world chose to forget. 8 big boys remain on display, testaments to American ambition and industrial might. 0 C63s survived, erased as thoroughly as if they never existed. But in 1950, for that brief moment on the Tokaido main line, a crew of American engineers watched a smaller, lighter, more efficient machine demonstrate what steam power could truly achieve. They saw the future of locomotive engineering. Then they went home and told everyone the big boy was still king, because some truths are too expensive to acknowledge.